Hey everyone, in this video we want to talk about the pop replicate node, which we can use among other things for something like this here. And as the name suggests, it's there to replicate points, which is a bit misleading. A better way of thinking about it, it's there to emit points from already existing points during a simulation. We will talk about this example at the end, but let's first start with a more simple example. What we have here is a single sphere that I turn into a volume so that we can scatter inside, and then I use a normal scatter onto surface in my pop source, and then importantly I only emit for the first 3 frames. And then these points get a start velocity that is diagonal around this direction, and then the whole thing looks like this, just a couple of points flying in a parabolic curve around the scene. So why do I use this? Because what I want to show you now is that we can emit new points from these points. And for this, inside of the simulation, we have pop replicate. And if I just put this in, and let's quickly not have the ground plane visible, then you can see that all of a sudden we get way more points than before. Let's turn it on and off so that we can see that. So that's the first thing. The pop replicate actually creates new points around our existing points, which will look like this if you would just run it. So what this pop replicate is actually doing is it works like a pop source, but it uses the pop source as the source of where it should emit from. But there's one important difference, and this is what we see here. It doesn't emit from the point position directly, but under shape, it actually emits from a certain area around our points. And it's easier to see if we change that, because by default, the scale of this is pretty big. So first of all, it is in form of a sphere. And if you want, you can change this to different shapes, which we won't use here, but you can if you want. And if you scale it down, you can actually see better what it's doing. It emits new points around our already existing points in a certain area. And by default, this number is pretty high with a whole meter around. Now also we can control how many points we want, which is under birth, and this follows the same logic that we already know from the pop source. We have an impulse count if we want per frame or subframe and per second. So if we change the number, of course, we will be able to increase or decrease the amount of points we want. So let's say we want per frame something like 5 points for each point that exists, or maybe we do 10. Who cares? So let's lower our uniform scale for now, that we can see this better, and run this again. And here you can see that, yeah, there are points emitted around our existing points. Now it might look a little bit like, you know, there is a clump around it that moves with our points. So it's constantly kind of copying points onto it, but that's not actually what's happening here. It is actually constantly emitting new points, which we can tell by looking at the number of points. We start with 150 points, and then after 16 frames, we have 1,400 points. And later on, when it lands, we all of a sudden already have 2,250 points. So it's constantly adding new points. But it doesn't feel like that. And that is because, very important, the points that are emitted inherit all the attributes that the source points already had. This is kind of what the pop source is also doing. Remember, when we set any attribute on our source, our newly created points from the pop source will inherit these attributes. And the same is true for the pop replicate. Under attributes, you can find the exact same setting, and there's a star in the inherit attributes. And more specifically, there is an inherit velocity, and this is the reason why the points travel with our existing points, because when they are born, they get the same velocity. So let's play around with this and quickly set our inherit velocity to 0. And unfortunately, still the same happens as before, which is very confusing, and that is because that is a bug in Houdini that exists for quite a while. It's really frustrating, but inherit velocity of 0 basically creates an internal error or something, so it actually does inherit something. One trick here is to just set the inherit velocity to a very small number, like 001, and then all of a sudden what happens is what you would expect, and that is this. The points are created, but do not inherit the velocity. They will just fall down because they are starting without a velocity. And this is what I wanted to show you. This is what you can do with pop replicate. You can basically let your existing points scatter new points into the world. And if you're careful and set the inherit velocity to 0, which unfortunately you have to do by setting it to 001, really annoying, you can let the new points just fall out of your existing points, so to say. Another way of solving this, by the way, is simply not using the inherit velocity, but set an initial velocity. Let's leave the variance in there and see what happens. And here you can see it even looks better, because now the points will not just be created and fall down, but they will have a start velocity that is a bit random. So we have a little bit of a spray reaction where things are kind of flowing in all kinds of direction, which is nice. So you can use this for stuff like snow or sparkles or stuff like that. Or you could also just use it when you have, for our main points, a velocity that is going upwards by a high number. You can use that to create trails. So this then looks like this, where you can see points are leaving a trail behind while they're flying upwards. Now another thing about this, remember the pop replicate, just like the pop source, doesn't only have the start velocities that you can change, but also a setting that we talked about, which is important, which is the life expectancy. So the points that you create with a pop replicate will stay alive for a very long time, which is 100 seconds. If we lower this, you can see now that the trail that is left behind will basically die off instantly. Let's make sure that our created main points don't have such a short life expectancy, while our trail points have a low life expectancy, and then it looks like this. And this way you can create trails. So I would recommend playing around with this, but this is one of the most common ways of using the pop replicate, and we will actually use that in more detail in the next video. So we will talk about this again when we talk about fireworks. But besides this kind of concept of basically creating trails, there's another very common thing you do with this, creating new points on impact. So here, this is a simple example of what we saw before with the Gatling gun example. We have here a sphere with a start velocity of -100 that I actually then randomize to get a spray direction. And this is then supposed to hit this wall. And then internally, I give those particles a red color. And then currently the whole thing just looks like this. And it's a bit hard to see, so let's have a look at it maybe from outside by copying. By the way, you could also use the display options under geometry and increase the point size to a higher number, and then the points will just get bigger. But I personally prefer just copy a sphere onto my points, and then it's more visible as well. And then the whole thing looks like this. Okay, so unsurprising, this is what you would expect. Now what we want to achieve now is whenever a red point hits the wall, it should emit, like in a burst, new particles, just like we saw with the example before. Now for this we can use the pop replicate node, but if we just do this, we can see what happens. All our points will just, emit new points constantly in a certain area. So the first thing we want to change maybe is that area, which is really big with 1 meter in diameter. But that's still not what we want, because now we get a lot of additional points for all the points. We only want this to happen when the point is actually hitting the wall. Now, first of all, to make this a bit more visible, actually we could use another pop color after the pop replicate that will turn green, so that all the points coming out of the pop replicate will be green. So we do this by making sure only the points that come out of the pop replicate, which will be recognizable by their stream name. So when we look at the middle click, we have a stream pop replicate one and a stream source first input, which are the points from the pop source or the pop replicate. So let's make sure only the points coming from the pop replicate, there you go, will turn green, so that we understand a little bit better what's going on. And again, what we see right now is that all the red points will get points emitted around them. So how can we make sure that we only actually emit from the points hitting the wall? There are multiple ways of doing this. The first one I want to show is we use the pop solver and say whenever a point is hitting another object, it should die. And then in the last video we learned we can actually find the points that are dying, because the moment they die, they get an attribute dead set to 1, which is something you can't really read out. So I could show you that there is here a dead attribute, but we will never see this turn to 1, because as soon as it's turned to 1, it will be deleted. But during the simulation, the pop replicate will actually be able to see that attribute set to 1. So we can tell the pop replicate with the group to only emit new points for those points that have the dead attribute of 1. And then it looks like this. The red points are not emitting new points from the pop replicate, only the ones that have their dead attribute set to 1. And this is how now we can start to see what the idea is. Now let's quickly adjust this a little bit, because currently the pop replicate will simply inherit the velocity from the red ones. We instead will set the initial velocity with a nice big burst of 333, and then it looks like this. Well, maybe that's a bit too much. Maybe 111. Yeah, I think that's fine enough. And here you can see the idea. This is not the only way of doing this though. We have a couple of problems with that. First of all, the green particles that are emitted from the pop replicate will now die as well as soon as they hit our ground plane, which is also there, and will create a collision for our green particles. So a way to fix this is to not use the internal collision behavior. So let's set this back to unchanged, but we could use a pop collision detect that should kill our points on impact, but only for the points that are in the group source stream source first input. So this time we don't use the collision target, we just use the group. So it will not apply to all the points. Let's see if that worked. And it did not work. Let's see why. I think that has to do with the order. So currently we are replicating all the points from the dead attribute, which doesn't exist, because at this point nothing has died. This only then happens afterwards. So the order here is important. Let's put the pop collision detect before that. Let's rewind. Yeah, now you can see it works better. By the way, currently we don't see any collision between the points. This is something we'll talk about in a later video. This is normal, but we will be able to fix that later on. Now the third way of doing this is not using the concept of dying at all. So we're not using the dead attribute, so we don't even need a pop collision detect. What we can use is actually the attribute that we already saw in the last video, hit num or hit total. So what we could do is we can use the pop replicate to not emit from the dead particles, but from all the particles where the hit total is higher than 0. Now, at first, that seems to work, but there's actually a problem with that is not obvious. And that is when we use the hit total higher than 0, then that means the pop replicate will trigger even after the red particles have collided with the wall. Because when they fall down, they will still emit from the pop replicate, because then the hit total will still be higher than 0. So basically, after the hit, our red particles are constantly emitting green new particles. To be fair, maybe you can get away with this because nobody can see it, but it's not a very good solution. A better solution here would be to use the hit num attribute. Remember, the hit num attribute only is set to 1 in the moment there's a collision, and that then means that only in the moment of the impact new particles will be emitted, and this is a much cleaner solution. So be careful what technique you use, hit total or hit num. So 3 different ways to find our impact particles. Feel free to experiment around what works best for you, the dead attribute or hit num or hit total. Okay, so this is the core idea, and with this you can create all kinds of other things as well. For example, rain splashes is a good homework maybe for you. But what we've seen is, as a finishing example, basically the same thing, but just this time with a proper model and proper geometry. And the way I did this is actually, now that we know how to do it, pretty straightforward. Here's my Gatling. This is already animated. And from the second output, we get only the source point, which moves with my Gatling. So it looks like this. And at the top, there is the point that we are sourcing from. This goes into a normal PopNet. Nothing fancy here. I used in the pop source that very point as a source and emit 1 point every subframe. This then gets a darker color. So the projectile point is a bit darker. Then I use the pop collision detect that we saw for only the first stream, and whenever this hits something, it will die. Whoop, I accidentally changed my output flag. Happens to me as well. So then the pop replicate uses that information in form of the dead attribute that is used to then replicate new points. And here I set an initial velocity with a strong variance in the x direction, so that we have a strong burst in this direction and a little bit of variance in the other dimensions. I lowered, of course, the sphere area for this, and I'm emitting 500 points per second. I could have used the impulse count as well, with a life expectancy of 0.5 to 1.5. This then gets again a color, a white color, and then the whole thing, when we look through it, looks like this. Basically, black points are then emitting white points on impact. And then I copy this onto some mountain up geometry with a random p-scale, a random orientation, and then it looks like this. so that the whole thing gets a bit more, shape. I mean, yes, it does make sense to add the projectiles with the same shape, but nobody will see that when it's motion blurred, so I didn't care. And then together it looks like this. This is pretty much just the same as we just saw. The only difference that I showed you in the beginning is that we also have impact points. And there are more complicated ways of doing this, but my approach, which I think is easy to understand, is to simply take the same wall. I had to subdivide it to get better results, and then create a copy of my simulation purely to let my particles stick on the surface on impact. So there's no pop replicate in here. All I'm doing is I set my pop solver to the response of stick, just like we saw in the last video. And then I just make sure that I don't care about the particles that are flying, only the ones that are stuck to the wall, which of course we can do by blasting away everything that does not have the stuck attribute set to 1. So I do a delete non-selected. You could of course use the opposite and say stuck equals 0. Well, I did it this way. And then what's left coming out of my simulation are only the points that are stuck. What do I do with that? I again add some random orientation and color, but the main idea is I will now copy geometry onto this. And you might already guess what I do with this. I just use a Boolean to subtract this geometry from the wall. And this will look like there is now an impact point. Again, to make this look nice, I had to subdivide the geometry quite a lot. This will give back better results, but feel free to experiment around with this. And if I combine this then with the setup that we saw before, then it looks like my impact will actually break out geometry out of my wall, which is a pretty nice effect. And as you can see, the cool thing here is we can actually do this with a pop simulation, and it looks much more complicated than it actually is. So even with pops, we can create destruction scenes. So as you can see, the pop replicate is a pretty powerful tool, and we will look at another example in the next video, fireworks. But play around with these concepts to get a better idea about it. So I hope this video was helpful. So thanks very much and see you later. Cheers.